Everyone. In this video, I will be going over Cramer's rule. Cramer's rule is yet another method used in solving systems of linear equations. Taking a look at our vocabulary, we actually have a couple people involved. We have Colin McLaurin, who made contributions to Cramer's rule, a little bit controversial actually. Cramer's rule, determinant, Gabriel Cramer, for which Cramer's rule is named after, and the word matrix. So, starting off, Cramer's rule. Is a method of solving systems of equations using matrices, which if that word looks a little unfamiliar, it is just the plural of the word matrix, which we will see a little later on, and determinants, a word I'm sure you have yet to hear at this point. Okay, and the people we were talking about, we've got Colin McLaurin, and Gabriel Cramer. Both made contributions towards its discovery in the early to mid 18th century. So the drama surrounding this is Cramer's rule is obviously named after Gabriel Cramer. Okay? But supposedly Colin McLaurin published some special cases of Cramer's rule in 1748. And by special cases, what I mean is we are going to do two variable system of equations. So we have two unknowns and two equations. Okay, Cramer's rule works for a variety of systems. Okay, so Cramer's rule is possible for a 3 by 3 system, meaning we have three equations with three unknowns, and I'm sure we are able to use Cramer's rule for 4 by 4 and 5 by 5. Colin McLaurin was doing the special cases, meaning he was doing something, he figured out how to do Cramer's rule, if you will, for a 4 by 4 system of equations, okay, for a 4 by 4 matrix. What Cramer did is he took what Colin McLaurin was doing and made a general rule that applied to all square systems of equations, okay, meaning 2 by 2, 3 by 3, 4 by 4. Cramer is the one that made the general rule. So even though McLaurin was doing special cases at the time, Cramer generalized it and was able to get the credit for the discovery. So, how do we do Cramer's rule? Let's take a look at this. So first off, it's important to note that we can write any two variable linear system of equations in the following format. Okay? A1x plus b1y equals c1. And for our second equation, a2x plus b2y equals c2. Okay, so here it might look a little unfamiliar, but I basically have a two variable system of equations where my coefficients are a1, b1, c1 in the top equation and a2, b2, c2 in the bottom equation. Okay, so if the a1, b1, c1, a2, b2, c2 are kind of throwing you for a loop, those are just going to be numbers. They can be replaced by any numbers for a system of equations. Okay, so for Cramer's rule, we need to organize these numbers into matrices, okay, such that D is equal to, so let me create my matrix. Okay, A1, B1, A2, B2. So basically what I'm doing is I'm creating a matrix using these brackets, okay? And I'm taking all the variables out, okay? I have no X or Y in here, I'm just using the coefficients, okay? So when we take a look at some examples, I'm gonna be given a system. My coefficients of X for my D matrix are gonna be in the left-hand column, and my coefficients of Y are gonna be in the right-hand column, okay? And if you don't know yet what I'm talking about, or you're having trouble picturing it, once we get to the examples, this should be made more clear. My E matrix is going to be C1, B1, C2, B2. Okay, so in this case, I'm taking whatever is after the equal sign, I'm putting that in the first column, and then I'm taking my coefficients of Y and putting that in the second column. And then for my F matrix, as I like to call it, we're going to take A1, C1, A2, C2. And order is going to be very important here. So far, we're not sure what we're doing with these matrices, but you're taking my word for it, and it will all tie in once we get to this next part. Okay, so for any 2 by 2 matrix, okay, this is kind of split into 2 columns right here, if you want to draw a line. For any 2 by 2 matrix, the numbers are placed in one of 4 spots, okay? So if I'm given a matrix, this is just a general rule of thumb, okay? I have A in the upper left, followed by B, C in the bottom left, and D in the bottom right. Okay? To find the determinant of this matrix, I'm talking this general rule of thumb here, okay, we can use the following formula. A determinant of a 2 by 2 matrix is going to be equal to AD minus BC. So what is AD? That means I'm almost doing a cross multiplication, if you will. So I'm going to multiply A and D, and then I'm going to subtract B times C. Once we have found these determinants of D, E, and F, we can find X and Y by dividing, for X, the determinant of E by the determinant of D. And to find Y, we're going to take the determinant of F and divide it by, again, the determinant of D. Okay, so we're creating these matrices, we're finding these determinants by doing this cross multiplication process. And then our determinants that we find for D, E, and F, if we take determinant E and divide D, we'll be left with our value of X, and if we take the determinant of F and divide by the determinant of D, we'll find our value of Y. So I'm sure this is very ambiguous, okay, but let's apply this process to an example. Okay, so I'm giving the system x plus y equals 1 and negative 5x minus 2y equals negative 14. Okay, first off, let's start by labeling the coefficients. So I know a1 and a2 are going to be the coefficients of my x. So the coefficient of this top x, it looks like I don't have one, and whenever that is the case, that means our coefficient is 1. For a2, our coefficient of x in the bottom equation is negative 5. For b1, looks like I don't have a number in front of that y. In that case, my coefficient is 1. And for B2, my coefficient is -2. And then my C's, looks like it's 1 in the top equation, and it's -14 in the bottom equation. Okay, so now what I can do is I'm going to organize these coefficients into matrices. So for D, it's going to be A is in the left-hand column, B is in the right-hand column, so I'm going to have 1, -5. And the right-hand column might be, so 1 and -2. For my E, I have C's in the left-hand column, so it's going to be 1 and -14. And in the right-hand column, I have my B, so 1 and -2. And for my F matrix, as I like to call it, I have A's in my first column, so 1 and -5. And I have my C's in my right-hand column, so 1 and -14. Okay, so now what we're going to do is we're going to find the determinants of D, E, and F. So I am going to rewrite these again. Okay, so now what I'm going to do is we saw up above to find our determinant, we're almost doing this cross multiplication process. So I'm going to draw this little x here, which shows that I'm multiplying 1 by -2 and subtracting 1 times -5. So if I do that, got 1 times -2, that's my A times my D, minus my B times my C. So if I do this, 1 times -2 is going to be -2, minus 1 times -5, which is going to be -5, -2 minus -5 is the same thing as -2 plus 5, which means the determinant of D is going to be -2 plus 5, which is +3. Okay, so I'm just going to leave this here. Found the determinant of D. I'll come back to that a little bit later. So now we'll do E. First, I'll create my matrix. I'll copy it down, so I've got 1 in the A slot, 1 in the B slot, -14 in the C slot, and -2 in the D slot. Okay, so if I write these in the form AD minus BC, I've got 1 times -2. That was multiplying 1 and -2. Now I'm going to do 1 times -14. Always minus in between. Getting a little bit ahead of myself. Okay, so back to my pen. 1 times -2 is going to be -2. minus 1 times negative 14 is going to be negative 14. So now negative 2 minus negative 14, I can rewrite as negative 2 plus 14. And when I do negative 2 plus 14, I'll get my determinant of E, which will be a positive 12. So same as determinant D, I've got 12. That's just going to chill out for a little bit. I'm going to find the determinant of F, and then I'll be ready to solve for X and Y. So for the determinant of F, I'll rewrite the matrix. So when I do that, I've got 1 and negative 5 in the left-hand column. And I have 1 and negative 14 in the right-hand column. So now I'll do AD minus BC. So 1 times negative 14 minus 1 times negative 5. Order is important here. Okay, 1 times negative 14 is going to be negative 14 minus 1 times negative 5 is going to be negative 5. I can rewrite negative 14 minus negative 5 as negative 14 plus 5. So when I do that, I'll get the determinant of F, which is negative 9. So at this point, I've created my three matrices, D, E, and F. I found the determinant by doing that cross multiplication process, and I got the determinant of D as 3, determinant of E is 12, and the determinant of F is negative 9. So if I scroll down here, I need to use the determinants of D, E, and F to solve for X and Y. Okay, so when I do that, okay, X is going to equal the determinant of E over the determinant of D. So if I do that, for the determinant of E, I got 12. For the determinant of D, I got 3. So 12 divided by 3 is going to be 4. So I know my X coordinate will be 4. And for Y, I'll take the determinant of F, and divide by the determinant of D. Okay. If I take a look up above on my last sheet, determinant of F is negative 9. Determinant of D is still 3. And negative 9 divided by 3 is going to be negative 3. So the solution to this system of equations is going to be the point 4, negative 3. Okay, and to check that answer, you could either graph those two equations by hand, you could use substitution, or you could use elimination. That would be a great exercise to do. But we are not going to do that during this video. So a question you're probably thinking to yourself that I get all the time is, why would I ever use Cramer's rule? Okay, Cramer's rule, and there's another method that we will not go over, but if you are interested, just ask me about it. Cramer's rule in reduced row echelon form, okay, are useful when we have systems of equations that have 3 or more dimensions. The more dimensions we have, the more time consuming it is to use substitution or elimination. So if we had a really big system, that's when we'd want to use Cramer's rule or reduced row echelon form. But I will agree, for a 2-variable system, Cramer's rule is not the quickest, okay? But as I said at the beginning of the standard, I'm more interested in giving you as many options to solve systems of linear equations, and then have you pick beyond the standard, once we've taken the summative, which methods you choose to use and choose not to use. So at this point, let's go to some examples. I'm going to zoom in a little bit. So this is how I like to do these problems. Okay, not that my way is better than anyone else's way, but I like to stay very organized throughout because there's a lot of numbers, there's a lot of even letters that could confuse us. So first thing I'm going to do is I'm going to label each slot in my system of equations. So I've got negative 3x plus 2y equals 10 and 3x minus y equals negative 8. So I know this negative 3 is my A1, 2 is my B1, and 10 is my C1. Similarly, down below I've got A2, I've got negative 1 for B2, and negative 8 for C2. So now what I can do is I can create my three matrices. So I'll go over here. Okay, D is A's in the left-hand column and B's in the right-hand column. So I've got negative 3 and 3. In the right-hand column, I've got 2 and negative 1. Okay, let's just find the determinant of it. So let's do this cross multiplication. So it's going to be AD minus BC. So I have negative 3 times negative 1 minus 2 times 3. Negative 3 times negative 1 is going to be a positive 3 minus 2 times 3, which is 6. So I've got 3 minus 6. I can get rid of those parentheses. So the determinant of D is going to be 3 minus 6, which is negative 3. Okay? And just for support, I'm just going to put an A and a B above the correct columns here. So it's helped students out in the past where when they're not sure what to put in the left-hand column and what to put in the right-hand column, okay? People are familiar with the word dab. So it goes D, A, B. So if you're having trouble remembering, think dab. Okay, I'll do matrix E now. Similarly, if you're having trouble remembering which goes in which column, I've got C in the first column and B in the second column. People like to think ECB, that doesn't form a word, but ECBA, it's kind of a funny word. People tend to remember that. So for my C's, I've got 10 and negative 8. And then in my right-hand column, I've got my B's, which are 2 and negative 1. So if I do AD minus BC, I have 10 times negative 1 minus 2 times negative 8. 10 times negative 1 is going to be negative 10 minus 2 times negative 8 is going to be negative 16. If I get rid of the parentheses, I've got a minus and a minus, so I'll have negative 10 plus 16, which we know is 6. Actually, let me make that a little bit more clear that the determinant of matrix E is positive 6. Okay, and now I will do determinant of F. So I'll create my F matrix. Okay, and if you're having trouble remembering which column is which, it goes F equals A in the first column, C in the second. So we have FAC, FAC right there. So if I plug in my coefficients, I'm going to have -3 and 3 in the first column, and I'm going to have 10 and -8 in the second column. So I'll do AD minus BC, so I'm going to have -3 times -8 minus 10 times +3. -3 times -8 is going to be +24 minus 10 times 3 is going to be 30. 24 minus 30, I'll get rid of the parentheses, is going to be our determinant of F. 24 minus 30 is going to be -6. So at this point, we have found our determinants of all three matrices, D, E, and F. So we know that X is going to be negative, oh, no, it's going to be +6 divided by -3. And we know that Y is going to be -6 divided by -3. So if we simplify those, 6 divided by -3 is going to be -2. And -6 divided by -3 is going to be +2. So if I scroll down just a little bit, the solution to this system of equations is going to be the point -2, 2. Okay, let's go on to number 2. So I'll start off by labeling everything. I've got -4x minus 6y equals 8. So -4 will be my A1, -6 will be my B1, and 8 will be my C1. And 4x plus 3y equals 1. So 4 will be my A2, 3 will be my B2, and 1 will be my C2. Okay, so I'll set up my matrices at this point. So I know D So I'm thinking DAB, so I'm going to have my A's in my left-hand column, so -4 and +4. And then B's in my right-hand column, so -6 and +3. Okay, I'll do this cross multiplication here. So I know AD is going to be -4 times 3 minus B times C, which is going to be -6 times +4. -4 times 3 is going to be -12. Minus -6 times 4 is going to be -24. I'll simplify my parentheses here, so I've got -24. So those are going to turn positive, so I've got -12 plus 24, which means the determinant of D is going to be -12 plus 24, which is +12. Okay, now I will do the determinant of E. So I'm going to have C's in my first column, so 8 and 1. And I'll have B's in my second column, or my right-hand column, so negative 6 and 3. To find the determinant, I'll do AD minus BC. So A times D is going to be 8 times 3. Minus negative 6 times 1. 8 times 3 is going to be 24. Minus negative 6 times 1 is going to be negative 6. 24 minus negative 6 is the same thing as 24 plus 6. Which is going to be 30. Okay, and now I will do F. So for F, I've got my A's in my first column and my C's in my second column, so I'm going to have negative 4 and 4. And then 8 and 1. Find the determinant now, so AD minus BC. So I'm going to have negative 4 times 1 minus 8 times 4. Negative 4 times 1 is going to be negative 4 minus 8 times 4, which is 32. So I have negative 4 minus 32. So my determinant of F is going to be negative 4 minus 32, which is negative 36. All right, so we have all three determinants now, so we can scroll down a little bit. So X and Y. We know that X is going to be determinant of E over determinant of D, so that is going to be 30 over 12. So if we simplify that, 3 goes into both 30 and 12. 6 also goes into 30 and 12. So if we simplify that, divide both of them by 5, or 6, we'll get 5 and we'll get 2. So we get 5 halves. And then for Y, we'll have negative 36 divided by 12. And negative 36 divided by 12 is going to be negative 3. So these two lines are going to cross at the point 5 over 2, which is 2.5, and negative 3 on the y. That's the solution to our system of equations. On to number 3, 2 more examples left. I will label everything. So A1, at this point we're probably experts. B1, C1, A2, B2, C2. I'll create my 3 matrices. So D is going to be A's in the first column, B's in the second column. So I get negative 6 and 4. and then I have 2 and negative 2. So if I do this math, I'll do AD minus BC, so I've got negative 6 times negative 2. I forgot my negative sign right there. Minus 2 times 4. Negative 6 times negative 2 is going to be a positive 12. Minus 2 times 4, which is going to be 8. Simplify that without parentheses, I'll have 12 minus 8, which means my determinant of D is going to be positive 4. Okay, time for matrix E. Okay, that will be C's in the left-hand column, followed by B's in the right-hand column. So I'm going to have negative 4 and 6. And then 2 and negative 2. I will find the determinant. So I'll have negative 4 times negative 2. Minus 2 times 6. Negative 4 times negative 2 is going to be a positive 8. Minus 2 times 6, which is going to be 12. I'll rewrite it without parentheses, so I've got 8 minus 12, which means the determinant of E is going to be negative 4. One last matrix. F is going to be our A's in the left-hand column, followed by our C's in the right-hand column. So we have negative 6 and 4, followed by negative 4 and 6. So if we do our cross multiplying to find our determinant, we have negative 6 times 6. Minus negative 4 times 4. Negative 6 times 6 is going to be negative 36. Minus negative 4 times 4 is going to be negative 16. So if we simplify without parentheses, we've got back-to-back negatives here, so we've got negative 36 plus 16, which means the determinant of F is going to be negative 20. So at this point, I'll scroll down a little bit. So we know that we can now find our X, and we can find our Y. X is going to be determinant of E, which is negative 4, divided by positive 4, which is going to be negative 1. And Y is going to be determinant of F divided by the determinant of D. So we've got negative 20 divided by 4, which is going to be negative 5. So the solution to this system of equations is going to be the point negative 1, negative 5. Okay, one more example left. Same as usual, we'll start off by identifying our A1, B1, and C1. followed by our A2, B2, and C2. I will create my three matrices. So I'll have my A's in my first column, so -6 and 5. And I'll have my B's in my second column, so 4 and 4. I'll find the determinant. So I have -6 times 4 minus 4 times 5. -6 times 4 is -24. Minus 4 times 5, which is going to be +20. -24 minus 20, I'll rewrite that without parentheses. So we know our determinant of D is going to be -24 minus 20, which is a -44. I'll move on to my E matrix. So I've got C's in my first column and B's in my second, so I've got 6 and -2, followed by 4 and 4. I will find the determinant. So A times D is going to be 6 times 4 minus 4 times -2. 6 times 4 is going to be 24. Minus 4 times -2 is going to be -8. (24) minus -8 turns to 24 plus 8 because of the back-to-back negatives. So the determinant of E is going to be 24 plus 8, which is a +32. Okay, on to matrix F. I'll have A's in my first column, so -6 and 5. And I will have C's in my second column, so 6 and -2. Determinant is AD minus BC. So I'll have -6 times -2. Minus 6 times 5. So -6 times -2 is going to be a +12. Minus 6 times 5, which is 30. I'll rewrite it without parentheses. So I have 12 minus 30 is going to be my determinant of F. Which is going to be -18. Okay, so I have my three determinants now. So now I can finally solve for x and y. So when I do that, for x I will have 32 divided by -44. 32 and -44 are both divisible by 4. So if I divide 32 by 4, I get 8. And if I divide 44 by 4, I get negative 11. And for y, I'll have negative 18 divided by negative 44. I've got a negative divided by a negative, so I know it's going to be positive. 18 and 44 are both divisible by 2. So if I divide 18 by 2, I'll get 9. If I divide 44 by 2, I'll get 22. So the solution to this system of equations, as ugly as it may be, is going to be negative 8/11 and 9/22. Okay? That concludes this video over Cramer's rule, as well as the guided notes. If you have any questions, please come see me as usual. Have a great day, everyone.